Okay, so I think this one's going to be kind of fun. It's a table, and we're going to do multiple transformations. So given a table for the function f of x, create a table for g of x, and it has this function described with these transformations. So notice that we have in here a compression. Then we're going to have, that's a horizontal compression. Then we're going to have a vertical stretch, and then finally a vertical shift. Now what we do is we do it one piece at a time. I think that's the easiest way to approach it. So I'm going to put a little table over here. And like I said, I'm going to do the horizontal stuff first. So this was a horizontal one, and it was a compression. Right? And then this was a vertical stretch, and then this was a vertical shift. Okay, a little bit of abbreviating there. So I'm going to do just the horizontal piece first. So I'm just going to look at f of 3x. So what does that mean? What changes in a horizontal compression? The outputs stay the same, right? 10, 14, 15, and 17. What happens to the inputs? Well, they're each going to get multiplied by 1/3, right? Because it's going to be a compression, so it's going to squeeze in. So I'm going to multiply all my inputs by 1/3. So I'm going to get 2, 4, 6, and 8. Okay? So for this part, I'm taking f, well, yeah, I'm taking f of 3x, right? So I need my x's, I need them to equal, let's see, I don't want to write it that way. That's going to be confusing. I need to multiply them by 1/3. So you can just take an example, okay? So say you put in 6, right? Oops. Say you put in 6, you'd have 3 times 6, f of that, which would be f of 18. And that's supposed to be, if I go to my chart, my f chart, f of 18 is 15. But what was the input? The input was 6. So I should have a point 6, 15. And I do. And you could do that with all of those points. There's 4 of them. You could do that. Okay, so that's maybe the tricky part right there. Now we're going to go I'm going to start with my vertical parts. So I have to do the stretch first. So I'm going to do the vertical stretch. It's a stretch. So I'm going to make a new table. Now for a vertical stretch, the inputs are going to stay the same. 2, 4, 6, 8. But what's going to happen to the outputs? All of those outputs are going to get doubled. So the part that we're doing is 2f of 3x. So we're not going back to the original function, f of x. We're going to use f of 3x, and we're going to double those outputs. So I'm going to have 2 times 10 is 20, 2 times 14 is 28, 2 times 15 is 30, and 2 times 17 is 34. Then we've got one more piece of the puzzle, and that's going to be the vertical shift, which in that case we're, sorry about that, in that case we're adding 1. Okay, all right. Need a new table. So don't go back to the other 2 tables, because now we've got this new one that we're using. And so this is going to represent g of x is being represented by 2 times f of 3x plus 1. So now we're going to do this whole piece, which is g of x. And what am I going to do with my outputs? I'm just going to add 1. They're all going to shift up 1. And so I'm adding 1 to each of the outputs from the previous chart. Inputs stay the same, 2, 4, 6, 8. But the outputs are going to increase by 1. So it takes a little time to do it, but if you just take each piece individually, then it makes it break down and it's a little bit easier. We're not going to do this throughout the semester for everything, but it is an important component to look at this point in our chapter. And so we're kind of dissecting it here. But if you're thinking, oh, this whole semester is going to be this complicated stuff, yeah, I don't think so. Okay.